Okay, so I'm started recording. Yeah, Raj, you can continue.
Yeah, no, yeah, just wanted to welcome everybody and then yeah, thanks for joining. And Piyush is going to present a paper on model. What is this?
V-JEPA. V-JEPA.
Okay, yeah. And this is a vision-based model, is it?
Yes.
Okay, cool. Yeah. So vision is not my strong suit, so it'll be a very interesting read for me as well. So hopefully we make the best of this session. Piyush, the stage is yours. Please, yeah, go
Okay.
ahead.
Okay. So actually, I prepared notes for this paper. Like I'm not created the article yet. Actually, I didn't have enough time. So I'm just sharing my notes here. So there, which I've prepared, and I tried to keep it in a form like as layman as possible, so that everyone can understand, even if they are not from the same field or maybe like they don't have enough knowledge about AI. So I will try to explain it as easy as possible. And I'm also not an expert, so we will be in a quite a ride together. Okay, so I guess everyone has joined. Okay, so let's move on to the main part. So first of all, V-JEPA is a research paper which is presented by Meta. And so this paper was presented by Jan LeCun. He is actually vice president and also a senior AI developer at Meta. So he said like he's actually quite famous on Twitter. Like he always goes around talking about some kind of spicy stuff on Twitter. Like if you go and check, he is always like talking like commenting on many things like which related to OpenAI and Meta and Tesla's. So he's always like reprimanding all those researchers who are basically in OpenAI. Like so he said that everyone who is thinking like AI will take over the world and all this stuff, they are just bullshit. Like it's not possible right now. Cause actually, I listened to his podcast. He came with Lex Fridman and talked about many stuff. You can check out his podcast here on the. Wait, let me share the screen. Advanced files. Okay. So it's only possible to share one screen at a time. Okay. Okay. So you can check out the podcast if you are interested. And here, that's Friedman. It's quite an interesting podcast. Jan. So here, it's this one. He talked about many stuff. Is like which also include V-JEPA paper. He also explained what is the paper about. So I will go let's try to explain it as in easier manner possible. So first, let's start with introduction. First of all, he model had like self-supervised learning has risen. Like it's become quite an interest in the following years, especially in the field of computer vision. With the use of this technique, the self-supervised technique, AI system should be able to comprehend their surroundings without the need of substantial human labeling. So basically, self-supervised learning method is a technique where you don't have to label data. Like it's quite a big problem where you have to like label billions of files and basically data, and it's quite a headache to be honest. Actually, I was trying to also like try to create a startup on this where I will create a AI model which will do auto labeling, but actually it was not a successful one, and maybe it won't work that well. So they created a technique where you don't have to basically label a data, and model will create some kind of self representation of this data. Where they first explained a technique which we call SIM-CLR, where it using contrastive learning, where contrastive learning means, let me share. So contrastive learning is a learning where the model will learn how, like learn to basically close the distance between two images which are similar, and also increase the image distance between images which are like not similar at all. Like they are using techniques where they augment the image in using multiple technique. It could be like random cropping, it could be like color changing, it could be like basically rotating the image. Like so they are using that technique here, and this like you can say construct loss the function where they minimize the agreement between negative pair. Negative pair means the like images that are not similar at all. Like they take the data set from that image and check if the images are not similar, then they will increase the distance. And if they are positive pair means they are similar, then the distance will close between them. And so but this technique has a like a flaw which they call like, which is like basically it requires lots of negative data to basically increase the distance between pairs which are not similar, and also decrease the distance between images that are similar. So they introduced a technique which we call bootstrap your own latent paper. You can also check this out. Like it's by, I guess it's by Google Mind. Uh, so this paper adopts a marginally different strategy. This paper adopts a marginally different strategy where they are using two types of network, which they call online network and offline network. Here, let me show you the diagram that they, okay. So yeah, here. One is an online network, and other is a of target network. The red one here is target, and what they are doing is taking an X input image, and they are basically augmenting the image in two different forms. Like it could be a T and T, T T minus. And then what they are doing is giving it to two networks. One is an online network which will like have a parameters and augment here online. What it does, online network, it doesn't learn from like in CLR they were the networks that they were doing is they were learning from each other. But here what they are doing is the online network is not learning from the target network. What it's doing is like on target net. Okay, let me take breath here. An online network that learns from data and make prediction. Okay, huh, yeah, here. Online, the online network, what is does is learn from the data and makes predictions. The online network is learning from the data and make prediction, and the target network that gets updated based on the online network prediction. And it's about is like a so you can take an example here. The target network is like a teacher, and that shows and the online network is how to learn from the data. The online networks learn from the data and make predictions, and the target network updates parameter based on the online network prediction. This process helps the online network learn from better from the data. The goal is to learn a representation that can be used for other tasks. And it's about exponential moving array. The target network is updating basically online networks exponential moving array that are always going to be the target networks are always going to be a lagging average of online parameters. And here you can see the formula. It's like this. Like Q sigma. Q is the prediction here, and Z is like the representation, like representation projection. You can just ignore this projection part. Actually, it's not that important. You can just take the representation here. Here is the function, and Z sigma is trying to predict the like trying to predict the target network prediction. It's trying to close the distance between two images. And so here is the formula. You can, I mean, if it's like it's not really important. And okay, let's move on to the JEPA part. The JEPA is actually using a little different way. Like it's not similar to BEOL completely. So most recently, researchers Meta, Facebook have developed a self-supervised learning yeah, here. So there are two the main paper that I was going to explain is V-JEPA, but they are using actually a similar strategy as image-based JEPA. So first, let me explain what is the image-based JEPA. I-JEPA is trained to predict the representation of different target blocks in image. So imagine here is the dog image. So what you will do is mask a part of it and then use the the network, deep network to predict the following masked area. And here, this is how they are doing it. So what they are doing is they are using context encoder to basically mask the image, and then it will use the predictor, the predictor function to predict the mask area in three different parts, and it will basically do this. So the key advantages of this approach are it doesn't need to remember every tiny detail, just the important concepts and relationship. It can adapt and generalize better to new situations since it understands the underlying rules. And it's more efficient than some other AI models because it doesn't need to process every word individually. Okay, so in this research paper, I-JEPA performs well on various image understanding tasks, often better than the other method that require more computational power. So this I-JEPA this model actually is using better, it requires less computation power than the other method that are actually available. So they believe this is a step towards creating AI that can learn and reason more like humans do. Actually, in Lex Friedman podcast, like this is human part is actually, I think, not the correct. Basically, in the research paper, Jan LeCun mentioned that his main goal is actually creating an AI model which will be able to behave like a cat. So, like, imagine, I'm not sure if you have a cat or not, but it's like this. Imagine a cat is sitting on a table. What it will do, it will try to hit some kind of stuff. Like maybe if you have some kind of cup on the table, it will try to make it fall down, and then it will understand what is happening. Like in the next, next frame, the image, the glass will fall on the full floor, and uh, the glass will fall on the floor, and basically it will basically cat will learn what will happen if the things fall down on the floor, and it will learn. Wait, actually, I'm getting a call. Let me pick a call first. So yeah, so what they're trying to do is make the model learn how and what will happen in the next frame. And that's how they used this approach with V-JEPA. And what they're trying to do is predict the next frame of a video. And in a latent space, of course, it's in a latent space where the model is like creating a representation of the video, the like predictions, and then updating it based on the world model that is available. Let me show you the world model here. Uh, okay, yeah. So it's not the a correct thing, but you can take it like this. This thing is a world model, and what the model will do, it will try to predict the on the base of an actor, which will take action in the world model, and it's not the correct actually. I will later on post the whole thing. I've not created the part. Okay, so let's ignore that. Okay, so what is IJAPA? It's the technique used to predict part of an input from other part. For example, if you have a picture of a cat, it predicts what one part of cat look like based on the another part of the case same picture. Uh, Okay, so it's different from another method called invariance-based speech training. So invariance-based speech training tries to make sure the representation of an image stays the same. Even if so, this technique is basically trying to create the same image based on the other image, even if the image isn't the same. Like if the image, even if the image is rotated, it will try to create the same image. And this actually other method that I have explained before, BYOL and bootstrap your own latent and SimCLR has a quite a problem. Like they can collapse. Like they have mentioned that the authors themselves mentioned that like this thing can collapse if cause imagine if the like models is trying to reduce the distance between online and target, not in Beol paper but in SimCLR. Like if they are trying to reduce the distance between the image and the then it will start overfitting. Like it will learn how the image will look like, and the whole model will collapse. So the hope with the JEPA is to avoid problems that can convert yeah this thing. For example, okay, let's ignore this. Goes to the main thing. Okay. So visualize. Okay, so here is the V-JEPA part. Similar to intelligent software, V-JEPA analyze videos. So what V-JEPA is doing is like it tries to analyze a video and attempts to decipher their content without explicit explanation. So imagine you have run a video, but you have stopped it at certain frame, and then what the model will do is try to predict what the next frame will look like. And suppose you have a friend, so here is an example. Suppose you have a friend who have, despite having watched a portion of a film, is an expert at speculating it on its plot. So like maybe if you are watching some kind of movie, but like a horror movie, like I was yesterday watching one. So what I will do is like basically watch it and stop it and basically try to imagine what, or not imagine, like speculating what kind of plot it will go towards. Like maybe hero will die or heroine will die or something like else could happen. So though with videos, VJEPA accomplishes that. It will try to predict the next frame, what will happen next. Its ability to deduce context from a single frame is sufficient. Rather, it examines the portion that are visible and extrapolate the missing bits. So here is a video. Actually, I will show you the video here, how they're doing it. Not this. Okay. So here is a video. You can. So this was actually a video where they explained how they are working. Where what it's doing is the model is doing is trying to predict the mask part of the image and try to make prediction on how the video, the next frame will look like. Like here, it tried to predict what will happen. So what V-JEPA thinks they're tearing something into two pieces. So they showed him the video where what will happen, and it told us about if the paper will tear into two pieces or not. And here, like the okay. So what they did was actually masked an image, like masked input image. And then what V-JEPA did, it made three predictions on if the page will have some kind of thing drawn into it, or maybe it will be an empty page, or if something else will happen, like maybe changing paper or maybe drawing something or writing something. So V-JEPA tried to predict all those situations by basically being trained on some less computational power than other probably like available models or maybe other stuff. And the reason it's unique, some techniques attempt to include every detail, every single detail in a film, which can be extremely time consuming and deemed unnecessary. So what other techniques do, it's basically, they try to like basically involve every single detail in a film. To train a model, you like basically take a whole chunk of data and try to feed it everything as possible. And basically a model learns to predict all those stuff. But V-JEPA doesn't require that. Here you can just mask part of images or pass part of videos, basically like maybe removing some frames or other stuff. And V-JEPA, what it will do, it will try to predict all the stuff like that you have masked, and it will create multiple prediction and latent representation space, and it will provide your prediction if you for the like some kind of other task you want to predict for or something like that. As a result, it can comprehend videos more quickly and intelligently. Grazing forward as of right now. Okay, so this part isn't that important. Okay. Future users, just picture the possibility of if your V-JEPA very could assist you. Okay. This is not important. Okay. I think I missed some part basically. Joint embedding. I guess this is all. Everyone can ask me a question, I guess. Uh, Maybe if you have some kind of question that maybe I've missed some part, like you can ask me if you want.
Hey, yeah, Piyush, are you done with the overview of the paper?
Yeah, actually, I've
Yeah.
completed most of it. But yeah,
Okay.
maybe I've missed some part, but I'm sure it's like enough for now.
Okay. Yeah. Okay. I mean, like, yeah. Overall, I think you kind of gave a gist of the paper, and I think you covered the critical points. And yeah, I mean, I guess the basic concept of the paper is very straightforward. You covered the architecture, etc. I don't have any specific questions. I guess I am intrigued enough to read the paper in more detail. But maybe I thought I'd take this chance to maybe give some feedback and maybe some tips for anyone else who wants to present in the future. So, typically when you present a paper, it's nice that you presented with your notes, but it would be nice if you spent a little bit of time, maybe 15-20 minutes practicing what you are going to say, because a lot of the stuff when you were explaining, right, felt like sometimes you were talking to yourself. Some of the things you decided on the fly whether it was important or not important. Having some slides really helps contextualize the overall discussion. A block of text is good, I'm not saying it's not, but slides really helps you present the paper in a more streamlined fashion. So I don't know about other people, but at least I had a little bit of difficulty following certain parts. The core idea, the core concept is clear. That's not an issue. But sometimes you kind of want to go from very high surface level information to in-depth information. And organizing your content via some slides really helps. So that's some advice that I could give you. And maybe if anyone else is listening and wants to present in the future, they can consider presenting it that way. So again, just some critique, some feedback over here on what would be more useful in the future if you want to present again. So yeah, that being said, yeah, thanks for presenting this. I think this is very important, especially the point that you made about creating a lot of negative data, especially from unlabeled data. That itself is a challenge. Um, there have been some people who worked on things like uh, multilingual, multilingual embedding models. And in multilingual embedding models, if you want to use them for aligning, let's say, sentences with the same meaning across different languages, um, you do have the concept of what is called as a hard negative. And a hard negative is a kind of a negative example which looks very similar to a given example, but has a fundamentally different meaning. So, for example, if you have a sentence like his name is Ajay, and then his name was Ajay. So these two sentences look very similar, but they have slightly different semantic meanings. So having these kind of hard negatives or negative examples really helps make a model much stronger. And I guess there are different ways of doing this. And one of the ways is the masking approach. The other way is to figure out the specifics of these kind of negative examples. So yeah, I mean, I think overall
Yeah, yeah.
there are some
Actually,
interesting points over here.
the the part about like basically using it for textual model. Yeah, there
Hmm.
are techniques available already.
Hmm.
While reading these papers, I also like went into how GPT was made, and they explained
Hmm.
it was using a self-supervised technique where they didn't
Hmm.
have to label all of the data, and it was quite like a good thing. Yeah, but
Hmm.
the part about not creating slides, actually, I was busy with my college and also
Hmm.
I just came back
So
actually from college, so I was busy and also didn't have enough time. But
right, right, right. So that's fine, but remember, you volunteer to present, right? So if
yeah,
you're
actually,
volunteering, it's better
it
if
was
you
my
do a
fault
good job
actually.
of it.
Yeah, yeah,
Yeah. I would much rather we not have a paper reading session in a given week than have one where not much of planning was done. Because everybody's taking time to join these sessions, so it's much nicer when everybody prepares and the session becomes more productive, more fruitful, more energetic discussions take place. Again, don't take this in the wrong way. I'm just giving you advice so that there will be more
yeah.
impactful sessions in the future.
Yeah, it's a good advice actually.
Yeah.
I know it's my fault actually. It's
Hmm.
nah, I'm just making excuses there. But
Yeah.
actually, what I will do is like create a basically simple to easy to understand article and share it
Mhm.
in, I guess, 1 or 2 hour. Maybe you guys can read it after it, this after the meeting.
Yeah,
So
please share these notes. Notes are you should share your notes for sure. Highlight them. Give some more
yeah,
comments and
actually,
information
yeah,
that
yeah, yeah,
people will benefit from. I'm sure.
yeah. And
Yeah,
also,
and
I
and
think
share the video also. Share this session video also, so that
okay.
people can take their own time, maybe go through it a couple more times, and maybe it'll make things much more clearer for them.
Yeah, okay. I will share that. Also,
Yeah.
I guess we should also discuss the timing. I'm
Mhm.
sure everyone is not agreed with the timing that we are following currently, like we are
Mhm.
following right now.
Yeah, so I'd like to open the discussion to people. Like, does Friday evening work for you, or are weekends more preferred? I mean, in my case, because I'm no longer a student, I have to limit my working time or everything that is work related to weekdays only. Is there any other weekday that works out optimally, or is it weekends only? In which case, I could probably figure out a way to make some extra time on the weekend. Any thoughts, any suggestions?
Uh, I guess I want to say maybe if I can we can do it on weekdays also. I mean, maybe like a little bit late by like 8 to 9 or maybe like in the basically in evening time. Like
Mm-hmm,
that time
mm-hmm,
will be like I will be available, but not for I'm not sure about others. Like I have
mm-hmm,
college
mm-hmm.
and also I get busy about that, and my teachers are like HODs are basically isn't agreeable like to leave early. So
Okay,
basically we
okay.
can move the
All
time
right.
to
So
that.
so so let me just then I'll do one thing. I'll float a poll on the channel, and then people can vote. We can come to an agreeable time. Of course, note that not everybody will be able to make all of these sessions, right? So I mean, we just go with majority vote and see what happens. So I hope everyone is fine with that. We just have a poll.
Yeah,
Yeah, I
that's all
think
right.
that be fine. Yeah.
Okay. All right, cool. Yeah, thank you everybody for joining. Yeah, the session ended a lot sooner than I planned it to, but that's totally fine. So let's thank Piyush, and Piyush, please share your notes, share this video, and we'll put it up on YouTube, and then people can take more time, go through everything.
Yeah, sure. I will do that.
Okay. Thank Thank you. Thank you.
Hello.
Hey, yeah.
Sir, meanwhile, like since we are having 20 minutes as of now, you can share some of your experiences. Meanwhile, we can share some experiences
What experiences would you like me to share?
related to like some of the projects you worked on, some of the challenges you faced, and how you resolved them.
I think it's better if we dedicate another session altogether for this. There's a lot of stuff I'd be able to talk about, and 20 minutes is not enough. And it's quite late for me over here. So I'd rather we do this
Sure,
on
sure.
another day where I have a lot more time, a lot more, let's say, mental flexibility. Yeah, happy to share my thoughts at that point of time, but probably not today. I'm so sorry about that.
Sure,
So,
sure, sure. Thank you, sir. Thank you for you joining at since it's too late at that. Yeah, for
Yeah.
you.
yeah, it's 10 p.m. in Japan right now. I just checked. It's four
Yeah.
hour
So,
long
anyways,
gaps.
right. So, anyways, let's end the session. And please share the recording and the notes, and then let's meet next week.
Yeah, sure.
Sure. Thank you, sir. Thank you.
Okay. Thank you.
Thank you, Piyush.
Thank you,
Thank
everyone.
you. Thanks, Piyush.